Hello, everyone, and welcome again to today's session Exploratory Data Analysis, Univariate Analysis. So, today we are going to be talking about EDA, as I mentioned, that is Exploratory Data Analysis. In the previous session, I have discussed broadly what is EDA, why do we need it, why do we do it, when do we do it, and how do we do it. There I also mentioned some, you can say, classifications of EDA, that is what type of analysis that we do on our data set, right? And previously I have done some analysis in the whole or overall data set, and today I told you guys I will be dealing with univariate analysis. So the topic for today is univariate analysis. Variate analysis. Okay, fine. Now the first thing, what is univariate analysis? Well, let me give you an idea. Suppose this is a data set having the columns A, B, C, and D. And in univariate analysis, what we are going to be doing is that we are going to be tackling each column. So we are going to be going column by column by column. All the analysis that we are going to be doing will be a single column based. Okay, single column based. This is why it is univariate. Okay, so the summary is one column analysis is basically our univariate analysis. I hope this is clear. Okay, okay, fine. Now let me again remind you that why do we need to do this analysis? Well, we do this analysis to find the flaws in your data set. As I have mentioned many times, when you collect the data, import data, the data is most often it is corrupted, it is uncleaned, messy stuff. This is why you need to clean this. But before you can clean this, you have to identify what is the troublemaking factor here. What are the things that I don't need in my data? This is where the EDA comes in. Okay, after you do the EDA, there is the cleaning part. Okay, there's the cleaning part, but for our session the topic is this part. Okay, fine. Okay, now in the previous session I also showed you hands-on on the Titanic data set. Okay, Titanic data set. So let's go to our notebook and import our Titanic dataset. Let's go. These are the agenda. I'm coming to that a bit later. So first of all, let's import pandas as PD. As we all know, these are the most basic libraries, as well as NumPy as NP. And we're gonna be importing our dataset, that is titanic.csv from Seaborn. That is why we also going to be importing import Seaborn as SNS. Let's run it. Yeah, it is finished. So let's bring our dataset. Let's call it df sns.load dataset. In bracket it will be Titanic. Let's run it. Yeah, let's see our dataset. df.head. I hope you guys remember from the last class that what .head method does. Let's see. It basically generates the first 5 rows of the dataset, not the total dataset. Clear? Okay, fine. Now, the thing is, for today's analysis, we not only going to be seeing the math and statistics. The bonus thing that we're gonna do is that we are gonna be doing graphs. Okay, we are gonna be doing graphs, and this is going to be our analysis. Now another thing, as I have mentioned, that we do analysis to find the flaws, right? To find the flaws. Okay, that is one thing, but we have to decide that which are the flaws. This is why the later part is making a decision. Okay, and we are going to be making decisions based on math and statistics, and to make our decision easier by analyzing, we are going to use graphs. Graphs make it look easy, make it look pretty, make it uh, very simple for all the data scientists or data enthusiasts or anyone working with the data set. Okay, the data visualization. And in my previous sessions, okay, if you can remember, in machine learning basic tools, I have covered 3 libraries for doing data visualization: matplotlib, seaborn, and plotly. Okay, since we have imported the data from seaborn, so let's use seaborn for our session today. Okay, okay, fine. So this was the goal of our analysis or of our session today, that what we want to achieve. Okay, fine. So we are going to be using seaborn. So if you don't remember how to use it, obviously you have to look it up, and you can do that by going to my YouTube channel and see the session again. There you can have idea, or do documentation reading or other YouTube videos, other lecture or courses, anything. But let me give you a small summary that we are going to be needing today. Okay, about seaborn, since we are going to be using seaborn plots and graphs. The syntax of seaborn, well, it is basically goes like this: SNS, as we have done the alias seaborn as SNS here, as you can see, seaborn as SNS. Okay, fine. Okay, the next thing is there's gonna be something here and then plot in a single word. Okay, overall it is a single word, then the bracket, then there's some very important parameters. We're going to be seeing that by using shift tab and the doc string, but you'll find in the doc string 2 mainly important feature parameters. One is data, that is the data frame. In our case, what is it? It is the Titanic .csv, which we have in the df variable. So we have to write df here. Clear? Okay. Then there are other parameters, lots of parameters, but since we are going to be using univariate analysis, we will be giving the column that we want to use in X. It will be printed on the x-axis of the graph. Other than that, you have Y and other parameters, which we won't be covering today, since our topic is univariate analysis. That is why we will be considering only one axis or only one parameter. Okay, so this is the basic structure or syntax of uh, creating plots using seaborn. And here in this gap you can have anything: KDE, you can have box plot, you can have like scatter plot, etc. Easy? I hope you got this point. Okay? Okay, fine. Now, before we dive into the our analysis part, one more thing. In a data frame, all the columns that you see here, are these the same? Obviously not. These are not exactly the same. There are some classification, mainly two classification. One is that some columns are categorical and some are numerical. Okay, this is why we need to tackle these type of columns differently. You get my point? Now if you're wondering what is categorical and what is numerical, well, 1 2 3 2.2, this type of numbers, if you have numbers in your column, then it is a numerical column. Or if you have classes like a b c, it can be yes or no, this type of classes, okay, categories, if you have those in your column, then it is a categorical column. Fine. Okay, I hope this is clear. Now it is done, or we understood that there are going to be categorical columns and numerical columns, and we have to deal with them separately in separate ways. Okay, now the thing is, uh, how can we find the categorical and numerical columns? Yeah, so let's do some hands on and let's figure out which columns are the categorical and which columns are numerical. So let's go let's have a new cell, and we're gonna write some codes. First of all, let's see all of the columns, shall we? All of the columns, this is an attribute, and see all of the columns are listed here, all of the columns. But to know which are categorical and which are numerical, we have to do some manual stuff. Let's say cat, and we're gonna be using something called select.dtypes include equals which data type do we want to include in our uh, cat variable. Since we are gonna be having string values in categories, this is why it will be object, or it can be category. And finally, we don't want all of the cells entries, we just want the columns. But let me first run it and show you what it is. You see, it is basically showing us all those d types, selected d types, which have object or category data type. Okay, like if you see that third man, these are all what? These are all object or category data types. This is why it is printing, but you won't find any price or any numbers here. Okay, there's no number. All the numerical columns are not here. Okay, fine. Okay, it is clear. But we don't want all the data set, we want just the column names. This is why at the very end we have to include a columns attribute, and you're gonna have all the categorical columns. Clear? And all of the data type is object. Clear? I hope it is clear. So we also have to see the numerical ones. So let's write new, let's copy it. Okay, fine. And in numerical columns, what we're gonna be having, we're gonna be having integers and floats, right? I hope you can understand. Integers and floats are numerical. Clear? Let's run it. Okay, it is giving me something error. Floats not on. Okay, I think there should be float 64 and integer 64. Let's run it again. Still error. Okay, no worries. I already have written all the necessary codes in case I make any mistakes. Okay, it is. Mm, well, let me copy it and then adjust it. It will save our time. Okay. Okay, then paste. Let's run it. Okay, it ran. Let's name it what? Num, as I have done for the previous one. Okay. Now if we print it, we are gonna get our values, but we have to declare another variable, cat column equals to df cat, and the same thing goes for this num and and let's run it. Okay. Okay, fine. If you want to see those, then we're gonna have to print it, print column, and again print column. Okay, 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 we are again getting everything. mm, okay, let me copy it whole so that nothing gets troubled. I'm basically just wanting to show you guys how the things are happening. Okay. Okay, invalid syntax, where the invalid thing, invalid thing, oh yeah. Mm, 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 mm. Here it is. Okay, fine. Okay, fine. Can you okay. Yeah, sorry for the delay, really sorry. Let's print it. Let's print our cell. Yes, as you can see, the categorical columns are all are present here and the numerical columns all are present here. Got it? It took a bit of time, but I really wanted to show you guys that it is very important to know which columns are categorical and which column are numerical, and how you can do it by using code. Okay, fine. Okay, now the thing is, we identified which columns are categorical and which columns are numerical. So we are going to be doing analysis, and we do analysis to find the flaws. Then in each of these, what are we seeing? Okay, what are we seeing? In categorical columns, we are actually going to be looking at the lengths. We're going to try to find out, are there any null or missing values? We are going to be seeing how many categories are there, right, and their count. Okay, so, and anything else, uh yeah, this is about it. Also the data type, if you like the data types, it is object, but still if you want to say it. And in numerical parts, there are lots of things. In numerical part, we are going to be seeing the lengths, also the null or missing values, are there any. We also have to see the variety, or if I'm not wrong, then it is, let me see what's the term, uh, 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 variability, sorry, my bad, it is variability. And what else, we are going to be seeing outliers as well. So these are the things that we are going to be looking for when we do analysis. Okay, and based on this, by using graphs, we are going to decide, we are going to make our decision. Clear? Okay, fine. Okay, fine. So now we can get in our graphical analysis of our data. Let's go. First of all, we're going to be covering the categorical columns. Okay, the categorical columns. Do remember the Seaborn syntax, as I'm going to be showing you the Seaborn uh, graphs. Okay, so first of all, let's see the count, and for that we are going to be using the count plot, and in data we have df. Let's print it, and here it is. Here it is. You have a count plot. See this? And as you can see here, there are some gaps here. There are some gaps. It is indicating there are some null values in the age column, sorry. In the age column, there are some null values. Okay, fine. This is an overall idea, but as a univariate analysis, it is going to be column by column, right? So let's do column by column. Let's see the count plot of each column. It's going to be a single, oh, it is showing the range, okay? The age ranging, and it is too much in the x-axis. This is why it is difficult to see. So let's try another column for our convenience. uh, let's go for class. Yes, since we are first tackling the categorical columns, uh, it is far more easier for us. Okay, now in this you can very easily make a decision that in the class, the third class, the number of people who are in the third class seat in our Titanic dataset is the largest. The second class is the second, and the first class, the total number, oh sorry, the first class is second and the second class is third. Clear? We are basically, if we want to see this in what the values, we can also have this, sorry, counts as, yeah, the numerical or mathematical stats, that in the third class it is 491, the first class has 216, and the second class has 184 numbers in total. And in the count plot we can easily see that. Clear? Okay, fine. So we have seen the categories. Here you can see there are three categories, but if there are too many categories, and if you want to know what their meaning, uh, how many they are, we can use another called this. See this? All the unique categories are listed here and individually shown. Clear? Okay, I have used df and unique. Let's do this one. Class. It showed the unique values of the entire data frame. This was the column 3. The number of unique values are 3. So basically guys, in our first example of the categorical columns, we have taken the class column and showed you by using value counts method, which takes all the categorical values in that column and also shows their total number. We also saw that how we can use a function and unique and get all the total number of categories. And finally we also saw in a graph. The visualization makes it really easy, right? Yeah. So what else can we do with the categorical stuff or categorical column? Very important thing is to know the null values, right? Yeah. So let's see the total null values in our each column. Okay, you see the deck column has too much, And if we want to find the null values in just the class column, let's see. There are no null values in class column. Are there any null values in fare column? Have any of the passenger in Titanic didn't give their fare? No, everyone gave their fare. Okay, okay, fine. What else? What else? Let's see. Uh, anyone? Did anyone not entry their name? Let's see who. No. So we can understand that when we took this, when we did this command to see all the count plots of the overall data frame, it gave us this plot. And by looking at this, we can see all of the columns don't have any null values except for the H1. Okay, except for the H1. All the columns here present in this graph don't have any null values. Clear? Okay, except for the H1. But it is not covering the entire data set, as you can see. I think some of the columns are missing here. Still, you get an overall idea. Clear? Okay. What else can we do in our categorical columns? Okay, see the length. We can see the length. It is very easy. Let's see. Let me give you an reminder that you can use shape attribute to see the shape. This is the total rows and total columns. Okay, easy, right? Okay, I think we can also use the uh, length to see. Yes, by using length we also can see the length column. Okay, okay, what else can we do? Let's see. We have seen the length, we covered the length, we saw the null values. Are there any null values in the column? We saw the categories, how many categories are there in our categorical columns, and we also saw the count in graphical form and in the numerical form. Data types, we all know in categories, it will be data type object or category. But still, if you want to see overall summary, then you can do df.info. It will show all the data types of all the columns and as well as all the non-null inputs. Clear? Okay, fine. So for the category columns, I think we have covered everything that is needed. Oh, we can also see the mode. We're coming to this. Okay, fine. Okay, fine. Okay, almost everything. We have covered almost everything as our agenda suggests. One thing remaining, a few things remaining to be exact. In this value dot counts, value underscores counts, you saw the total of people in each category, right? You can also have it in percentage. How? Let me copy it here by using this parameter normalize equals true, and you have a percentage almost 55%. If you do this multiplied by 100, then it will be better. 55% is in third class seats. Okay, 24% in the first class seat, and only 20% are sitting in the second class seat among all the 100% passengers. So this makes it easier, right? From seeing the numbers and having a guess, right? The percentage makes it easier. Okay, actually we are making it easy by doing this type of methods and graphs. Okay, anything else remaining? Yes, another thing that is remaining, that is to see the mode. You know what mode mean? Mode actually the most repeated value in your data. Okay, so if we do class dot mode, can you guess what will be the answer here? I have told you that mode means the most repeated value in your data frame. So as we have seen here, the third class is most repeated, right? 491 times. So it should return third. Clear? Okay. So guys, this is the basic categorical column analysis, okay, that you need to do. Among categorical analysis, this value counts is the most important actually and mostly used, okay. And other than that, I think we have covered almost everything in our agenda for today. In categorical columns, we have seen the frequency distribution, relative mode. Okay, okay, you can have a homework to build a pie chart of the value counts of this, okay, by using matplotlib. Remember, Seaborn doesn't have a pie chart. For that you have to use matplotlib. If you have forgotten matplotlib, see my matplotlib session, okay. But still I am giving you the code as I have it here. If you fail, you can try this, okay. It will give you a pie chart of the percentage of the value counts. Clear? Okay, fine. So we have covered the basic univariate analysis of every categorical columns. I've just shown you a few. I've taken the class column, right? If you have done anything else, like uh, what else can we take? Let's take who. If you take who, you will also see there are men 60%, women were 30%, and 9% children were in the ship Titanic. Clear? So I've just shown you one or two columns. You can input any column name as you like and you will get your answer. Clear? Okay. So we are done with the categorical columns. Let's go to our numerical columns. Okay. In numerical columns, as you can see here, we're going to be seeing these stuffs. So let's start the hands-on. Let's go. What are the numerical columns here? Let's print those first for our convenience. Let's copy it and print it here. So these are our numerical columns. Let's do quick analysis. Okay, let's start. DF, let's which one to take? Let's take fair. Okay, let's take fair and let's see the length. What should be the length here, guys? It should be 891, right? Oh, sorry, it's gonna be len. Put the len, yeah, 891. Since there are 891 entries of fair. Okay, fine, good. Let's see, are there any null values? Are there any null values? Dot is null. Dot sum to have the total number. No, there are no null values in fair column. Okay, fine, fine, awesome. Now we want to see the fair column. Okay, how can we do that? By using distribution plots. Another thing, if you guys don't remember what is distribution plot, let me give you a reminder, short reminder of Seaborn. In Seaborn you have lots of graphs and plots. Just go to the documentation, go to the API reference, and here you will find all sorts of plots that are present in Seaborn. Okay, You see categorical plots, all of these are categorical plots, these are regression plot, and for numerical we are going to be using these distribution plots. Okay, if you have forgotten, please go to the documentation and check for yourself. Okay, okay, fine. So let's get back to it. Let's build a dist plot or hist plot. Okay, it goes like this. Our data or data frame is df and the x value is fair. Let's print it. As you can see from this, what can we guess? We can guess that most of the passengers are in between this range 0 to 50, right? About 300 passengers are in this range, and very few passengers gave a fare more than 200. I think it is countable here. I think it is 5 or 4 people gave 200 plus fare, and only one here you can see gave above 500 in fare. Okay, to make it a bit easier, we can see the KDE plot of this. Okay, this is the KDE plot. Now, numerical columns have lots to show us. Okay, so in order to understand that, we're gonna have to know a bit of theory. As you can see here, we're gonna be looking at, we have already looked at length and null. Now we are going to be seeing the variability and outliers. These are really deep and vast topic. So I need to give you some theory about this. In the previous session, I have told you something about skewness. Okay, this is a kind of variability. In variability, you're going to having these terms: skewness. You're going to be having var, variation. You're going to be having STD, or it is called standard deviation. You're going to be having Z score. All of these represent one thing: variability. What is variability? In a broader term, it is basically meaning how your data set are spreading, how much they're spreading. If the values are bigger, that means the values in your data set are spreading really far. Okay, if it is short, it is not spreading too much. Okay, okay, let me give you a better idea of this. First of all, let's cover skewness. I've already covered it in broader term in last session, but still, this is called a bell curve or a normal distribution. If your distribution of KDE plot looks like this, that means 50% of your data are within this range. Most of your data are within this range. This is the ideal position that your data should be, or your data should look like. Okay, but in many cases the data are not like this. It is either like this, it can be like this. Okay, it may be in other forms. I have discussed this type of graph is called right skewed, and this is left skewed. This is not ideal. The ideal part is this, having it in the middle, the peak in the middle, not in one side. Okay, this means 50% of your data are ranging somewhere here. Okay, while some data are spreading out right side, on the right portion. Okay, this is not ideal. It creates inefficiency in your model. Okay, so this is why you want to have your data in this form. Okay, this is the decision that we make by seeing our KDE graph. Okay, after seeing the KDE graph, we compare with this one and assume whether it is skewed or not. If it is too much skewed, then we have to manually tweak in to make it a better one. This is the purpose of seeing the KDE plot that we have here. Okay, from this we can see most of the fair values are within this range from 0 to 100, as the peak is here. But there are also values going in the 500 path. Okay, but it is in almost touching the x-axis, meaning there are really small amount of people giving this fare. Clear? The larger the peak, the greater the number. The smaller the peak or slope, the lesser the number. In 500 it is almost touching to 0. Okay, I hope you understood the skewness part and what KDE plot means. Okay, now for the variability. In variability, another three terms are important. It is called central tendency, and here we have to study mean, median, and mode. Clear? These three things. And also the things that I have mentioned earlier: var, that is variation; std, that is standard deviation; iqr. iqr basically means the 50% of data, most of the data lies in that range. So in this case, this range is the iqr, interquartile range, where the 50% data is present. This range from this to this is IQR. I hope this is clear. Okay, fine. Okay, fine. So let me elaborate a bit more again with our bell curve. The variation, suppose this is the middle ground or the mean. The further you go, the bigger the variation and standard deviation and z-score is. All of the three terms are meaning the spreadness of your data. The bigger they are, okay, the larger the spreadness. Variation has a value. If you square root it, it becomes standard deviation. And z-score is also something like this. It is basically something, if I'm not wrong, yes, it is something like this. It is a formula. So basically, all of these things, variation, standard deviation, and z-score, all representing the same thing, variability, but in different ways. I hope I'm clear. Okay, the larger the value, the greater the spread of the data. Okay, fine. So let's see some hands-on. I have shown you the theory of of what is mean, median, mode. Okay, I have not covered this one. The mean is average, the average value. Hope you can understand. The median is basically the middle point, the exact middle of your total data. And the mode means the thing that we can find the maximum number of. Like in the categorical plot, we seen that the third class was found 491 times, the maximum times we found the third class. This is why it was the mode. Similarly, here also, the max number that we can find in our data is gonna be called mode. And I have told you about these things as well. So I'm hoping the theory is clear. Okay, fine. So we have covered what is KDE plot and how we can understand the skewness by seeing the KDE plot. So for your convenience, let's see another KDE plot of the column, let's say age, and let's see what we can assume from that. Okay, this plot looks nice. As you can see, it is almost a bell curve. It is almost in the middle peak. So we can assume that the age are symmetrical, or the distribution of age is quite good. Okay, if you want to see other, let's see the perch. Oh no, here the data is also really bad. The distribution is really one-sided. Most of the data are in the on the left part. It is a right skewed plot. Okay, so similarly you can make an assumption of your columns by seeing the graph. Clear? Okay, fine. Now we want to see the uh, mean median modes. So let's see them. Of fare dot mean, the mean is 32. The average fare that the people gave in Titanic is 32. Okay, let's see the what median, the middle value. Okay, median, it is 14.45. So 50% of the fare was below 14.45 and 50% of the data or fare was above 14.45. So the median is so low, suggesting that most of the people, 50% of the people, gave below $14. Okay, so it is making the assumption, the realization of the column really easy for us. Let's see the mode as well. The mode, okay, it is 8.05. So the maximum number that the people paid is around $8. Clear? You see how we are analyzing the fare column? We have seen the average that the people gave. We have seen the what is the middle point, 50-50, and we have seen the maximum people gave what amount. It is 8.05. Clear? Okay, so we have covered mean median mode. Anything left? Let's see. We have seen the variability. Another thing, you can also have a look at the standard deviation and the deviation variation. Okay, let's see that as well. Since we are seeing everything, it goes as STD. The deviation is not too much or not too less. Okay, okay, it is almost 50, but it is not too less. Actually, okay, it is not too less, or we can say it is on the upper side. Okay, okay, fine. Here like this, similarly you can see the variations as well. Here it is the pure variation, nothing in the formulas. This is why it is so high. Okay, okay, fine. The next thing that we need to study for analysis is called outliers. Now what is outliers? Let's go. Again, giving a reminder, all of these are actually mathematical formula, all representing the same thing. This is why their values differ. Okay, okay, fine. If you have more interest in these things, do a little bit of YouTube search and you'll find lots of people explaining this. But this is not the main topic of our today's discussion. This is why we're not getting too deep in it. Okay, so the next thing and the final thing for our session is outliers. What are outliers? If you have some data here, and a data here, then this data will be called outlier. Okay, I hope you get the point. Most of the values are in this range, but this thing is way far. But you might ask, so what? So what? So what if it is too far away from the regular range? It is a bit a naughty type data. So what? The thing is, it creates inefficiency. Just think of it. If you were to calculate a mean of the data, excluding this, the mean would have been here, somewhere here. But if you include the mean, including this, then it will be somewhere here. So, for one or two data point, you are neglecting the opinion, the characteristics of majority of your data points. It will create inefficiency. Okay, this is why you don't want outliers in your data set. Either you want to delete those, okay, or you want to manage those. But before that, you have to identify this, right? Yeah. So to identify outliers, we are going to be using graph. Okay, and the graph that we are going to be using is something called box plot. It is called box plot. It is a huge topic, but I'm going to covering it very fast. It looks like this. Okay, and what does this mean? From this portion means the 50% of the data. Clear? This above line means the third quartile. This line means the first quartile. I'm coming to the uh, what do they mean? Okay, you will also be having a line like this and a dotted line like this. This line means the mean, and this line means, sorry, this line means the median, and this line means the mean. So it is really easy, right? So many information you can get out of one data or one table. This is 75%, and this means the 25% of the data. But how? Actually, this line that indicating the first quartile means from this to this is the 25% of the data. You will be having a y-axis, right? And lots of values will be here. So from the first value up until this point will be the 25% of the data. From the first point to up until this will be the 75% of the data. And if you just minus it, you will have the 50% of the data or the maximum data. Okay, clear? I hope it is clear. And this line, by seeing and comparing it with the axis, you will find the x value. This means it is the median. Compare it here, you might find y value. This is the mean. Okay, okay, fine. So from just looking at this, we can see this is the IQR, by the way. This 50% means the most of the data is ranging from this to this variable. Suppose this is x2 and this is the x1. The interquartile range or IQR would be Q3 minus Q1 or here we have x2 minus x1, this range. Clear? Okay. Now this portion, these two portion means 1.5 times the IQR, 1.5 times. If there is anything above, these are called outliers. Clear, guys? Or anything below is called outliers. If there is no outlier, then this is the max value and this is the mean value. But if there's outlier, if there's anything above or below this, then this is the 1/5 of the IQR. It might seem a bit of uh, tricky, okay, but do watch and rewatch the video to understand it fully, okay, if you don't understand at the first time. But can you imagine just looking at one plot how many things we are covering? As you can see, we are seeing the median, we are seeing the mean, we are seeing the IQR, we are seeing the third quartile, the first quartile, we are seeing the outliers. Everything we are seeing by using this. So it is so easy, right? By looking at just one plot. Okay, but let's see it in hands on. Let's practice it. Okay, fine. Let's see this. The code will be sns.boxplot. Boxplot, the data would be the df, and the x value that we are doing now is called fair. Let's print it, and you have your box plot. Here it is horizontal. You can also place it vertically, no problem. As you can see, this is an outlier, and these are also kind of outliers, right? And the most values are ranging from 0 to I guess 100, right? So like this, you can easily identify the outliers as well in your column and have an overall idea. So guys, a long session, but let's see what we have covered. Let's see them. We have seen categorical columns and numerical columns and did univariate analysis. Okay, we have seen how to do frequency distribution, how to see that, how to see mode, how to see missing values, or also visualize them in categorical analysis. And for numerical analysis, we have seen the summary. Oh, you can see the summary. I didn't cover this. You can see the summary of the entire data by using describe. That's it. I've covered that in the last session. Here you can find the count, the mean, the standard deviation mean, first quartile, third quartile, the IQR, the max value in one go. So this is very important and gives you a overall idea. Clear? Okay. Okay, fine. What else did we cover? We covered the central tendency, mean, median, mode. We saw the variability, KDE, variance, standard deviation. By the way, it is not variation, it is variance. My bad. We saw the range, IQR. We saw that by using box plot. We have seen distribution shapes, skewness by using KDE. We have seen the outliers, the missing values, and also saw visualization by using Seaborn. Again, if you have forgotten what is Seaborn, how to use it, you can go to the documentation and look for it. Okay. So guys, this was about the univariate analysis. In the next session, we'll be covering bi and multivariate analysis. Okay, and we'll be seeing lots of graphs. and those will be very colorful graphs as well. So if you don't want to miss that session, stay tuned and do join. So up until then, bye bye.